Welcome to this Aspen tutorial about pumps. Today I'm going to show you how to select a pump, how to put it in Aspen, how to put the pump curve in Aspen, how to put the efficiencies in Aspen, and how to get your results for your pump. So first we have to define our components, and in this case I'm only using two components, and those are water and an organic component. And in this case it will be, in my case it will be isopropyl alcohol. So we put in this one. Okay. Okay. So my my properties are now right for my components, so I can proceed with the simulation. I want to put in a pressure changer or a pump, so I select it with two streams. I will call them in and out. And now we can define our input. The input you want to use is, it depends on what there is in the sheet you got from Professor Boosten. In my case I will take a 10,000 kilograms per hour stream, and first I will do water, and for a pump it's important that there's only liquid, so a good estimate is to put your temperature in between the melting and boiling point. So in this case that's 50 degrees. Maybe for the isopropyl alcohol we will change it later, but we will see. Maybe it just works also at 50 degrees. So in the first case most of it water, only a bit isopropyl alcohol. Okay. Now we can proceed to the block. Yes. So this is the pump, and we want to increase the pressure by 2 bars. So, and now we can let Aspen do the calculation. Oh, I made one mistake. As you can see here, the component mass flows are not are normalized. So probably, yes, I see what I did wrong. As you can see, there's no mass fractions here. So I will change that. It's good to reinitialize if you have warnings or errors, because Aspen will keep calculating with the answers from the last time you tried. So okay, now we don't have any errors. Now we can look at the results. We can look first at the main flow sheet. We can see that 10,000 kilograms of water is about 10 cubic meters of water an hour, but that's not really surprising. 2 bar pressure increase. So this is just what Aspen calculates what you put in. Of course, this is not what is happening in reality, because normally you have to choose some kind of pump, and you can't choose any kind of pump to do exactly what you want. There are limitations to that, but I will show you. We can look at the pump now and at the results, and you can see that we're pumping about 10 cubic meters of fluid here, and we need a head that's a measure for the pressure, or the pressure that the pump needs to give, so of 21. So if we want to select the pump later on, these two numbers are important. I will also now look what happens if we use isopropanol, or mostly isopropanol, because then we can specify a pump that can do both isopropanol and water. Okay, no warnings, and we can look at the results again. And you can see now it needs 26 meters of head developed, of HES, in our case has developed 26 meters of head and with a volumetric flow of 13 cubic meters per hour. So this is an increase, so we have to take this into account. So if we want to select a real pump for a real life purpose, we have to look at a brochure in which they sell pumps, and Professor Booston put this in your assignment. He put in 2 links, and the top one is an there you can find all kind of pumps, and in the second one you can look at the specific pump you've chosen. So I've already got the 2 links here. This is the first link, and we have to select the pump, and these are all pumps and with the pump ranges, and we can now select our pump, and we had to have a pump that could do in between 10 and 13 cubic meters an hour, so we're in this range, and it had to develop a head of about 21 in between 21 and 26 meters. So I think we can maybe take this one. I think we will do it, yeah, not perfectly, but it will be alright. So I will take the 32 125, and I already selected it here. And now you have a more detailed look, and now you see 3 pump curves, and these are for the various impeller diameters you can choose. Now we had to take a pump that could do in between 10 and 13 cubic meters, so that leaves us with the top 2 impeller diameters, and it had to do in between 21 and 26 meters of head. So this one is the only one that can do 26, and it can also do 21, so we will choose this pump. So how do you put this pump in Aspen? If we go to Aspen, back to Aspen, you can click on the pump, and instead of saying I want a pressure increase of 2 bar, you will let Aspen calculate the pressure increase by using a performance curve or the pump curve. So okay, and now you have to use the pump curve. You will have to put in the pump curve, and you can do this as follows. You will select volume flow here, so you will base your performance curve on head and volume flow, single curve at operating speed, and now you can put in the curve data. So you can put in the head here and the flow in here, and you can just read it from the chart. So if you go back, for instance, you always have to have a starting point. It can't be 0, but it has to be close to 0. So you take 0.01 and you will set it to about 27. Then you take another point, for instance here, 4, and you will say at 4 cubic meters per hour the head is 20, like 26.4, and then you take another point and another point and another point until you got the whole curve. I already did this, so I will put in my data. I hope this works. So I put it in. Now you can also look at your pump curve, and if it's nice, and if it's the same as from the booklet. So you can, it's a bit different in the previous Aspen version, but you can also do it there. So you can say on the x-axis I want my flow, and on the y-axis I want my head. And you can see this is our pump curve, and I think you can develop 26.5 or maybe a bit more, 26.5 meters of head, and you can have it in a range of 0 to 18 cubic meters an hour. Okay, so now we've put in our curve data. We can see how this influences our result. So I will go back to the main flow sheet. So all the input stays the same, but what happens? Let me show you. So no errors. The pressure isn't exactly 4 anymore, and that's because now Aspen calculates our pressure through the pump curve, and at 10,000 um, kilograms an hour, the pressure increase is 1.72. So we have to get to a point where our pressure is has exactly increased 2 bars, and the easiest way to do this is by um, putting in a list of points for the flow here. So we will vary um, the mass flow rate, and we will look at how the pressure changes. And the way you can do this is by the model analysis tool here, and then the sensitivity options. You will make a new sensitivity, yes, and you will vary, as I said, you will vary the mass flow. So you can select stream variable of the inlet stream and then the mass flow. Um, we will give it a range of now let's say 1000 kilograms an hour until uh, 10,000, because we know 10,000 works, and we will let Aspen create 100 points. Okay, so what do we want to measure? We want to we first have to give it a name, but you can just call it press or press out, for instance. And now you have to say what press out is. But what we want to measure is the pressure of the outlet stream. So we can say here stream variable, the stream variable of the outlet, and then the pressure in bar. Okay. Now we have to make a table out of this. The way we do this is okay. So now we can run it, and we will see what happens. Okay, it has calculated a lot of values, as you can see here. 100 points, 101, I don't know exactly. And you can look at the results of the sensitivity. And as you can see, every time Aspen takes a new value of the total input stream, and it calculates the output pressure. Now we can also plot it, of course. So mass flow on the x-axis and pressure on the y-axis, and you can see we have a pressure increase. Oh, this is not exactly okay. What the problem is that, as you can see, with the isopropanol, it doesn't reach the 4 bars or the 2 bar increase I intended, and that's because with our pump selection, um, as you can see, we required um, at least 26.6 meters of head, and so that's awfully close to here. So that's first, it's not really efficient to choose this pump if you want to have a 2 bar pressure increase, but I think it's not really important for now, because I should have chosen another pump for the isopropanol, but for the water it probably will work. But we can see, because we can have a look for water. If we set it to water, we probably will get the 4 bar. Let's have a look. Yeah, so we get 4.5 bars. It doesn't update. Okay, so now we do get the 4.5 bars. So if we want to know what exactly 4 bar is, we have to extend the range, as you can see, because it's here still 4.34. So let's broaden our input range from 10,000 to 15,000 and see what happens. Okay, no errors or warnings. Um, okay, so we just got it. We can plot it. Okay, so if we want to have exactly 40 4 bar outlet pressure, so 2 bar pressure increase, we have to be at something like 14,500 kilograms an hour. So we can put that into our input. Let's see what happens. And if we now look to our main flow sheet, you can see we have exactly the 2 bar pressure increase we want. Okay, so for my organic component, this pump wouldn't work to increase the inlet stream by 2 bar. I would have to choose another pump, but I think the way to do it is clear, so I will hope you can also do this with your component, and we'll choose the right pump. Another thing I want to show you is how to put in the efficiencies, and that is quite similar to putting in the performance curve. As you can see, here put in the performance curve data. There's also a tab efficiencies, NPSHR, and operating spec, and you can all find these in the pump curve booklet. So you can see here, this is in the beginning you don't have a lot of efficiency, so it would be wise to choose a pump and choose it in a way that you have high efficiency, so you're in this area. But that's not always the case, but just try to. You can put in these numbers, so at this point, like at 1.3, the efficiency is 10%, 20% here, 30% there, and you can just read it just as you did with the pump curve. You can see here the impeller diameter, and the impeller diameter is, I think, in millimeters, and for the like, what did it say, or did it call it here, the operating specs, the operating shaft speed is displayed here, so 2900 revolutions per minute. And let's see what else do we have to fill in. Here, the net positive suction head, you can find it below here. So this is a requirement for the inlet of the pump, and I think most of you, because we are already at 2 bar, won't have any problems with the input specification, but you have to put it into your Aspen file. Okay, so the efficiencies, you can fill in the efficiency here correlated to the flow, and the same accounts for the net positive suction head to the flow. I think I probably have told you about everything. Yeah, there are more assignments or assignments that require you to install 2 pumps in parallel or 2 pumps in series, but it's almost the same. And I think with what I just told you, you can also do these assignments. Okay.